right, so what we are working on today, and hopefully you have your note catcher open, so as we go through this, you'll be able to keep up. We are looking at some of the major properties of water. We are going to look at how polarity is responsible for a lot of water's properties. And additionally, we are going to be looking at polar and non polar substances and how they behave with respect to water. We'll talk about density, heat capacity, heat of vaporization, and how these things are important to living organisms. Because even though we've been talking a lot about chemistry, this is still a biology class. So our focus is always going to be how do these things impact living things, the ability for living things to be alive, to thrive, to go through their life processes. All right, so we are now on the first question where it says water life and the water molecule. So without water, life on Earth would not exist. Okay. There is no form of life that we are currently aware of that doesn't require water. If you recall, when we talked about the various different characteristics of life, we said that living things were organic and that organic things could either be alive, they could be dormant, or they could be dead, right? So when you look at something like seeds, the reason they're dormant oftentimes is because their environment is not conducive to them being alive at that moment. Oftentimes, the thing that seeds need most to quote come back to life or leave dormancy is going to be water. Okay. Um, it is vital to the survival of all living things. I'm sure you've seen pictures of animals out on the savannah. Lions and gazelle and elephants and all these, animals that normally are kind of like at a crossroads with each other, predators and prey. They all learn to behave themselves around the water hole because water is essential for everybody. Your body, my body, the human body is about 60 to 75% water. That is why oftentimes like your coaches, your parents, your teachers, people, the adults in your life are always telling you make sure you stay hydrated, make sure you drink water. Um, Literally your body does not function without it. Lastly, our planet Earth, is covered with 75% of our surface is covered with water. Fun fact, the fresh water that exists here on planet Earth, we have the access to most of the liquid fresh water on planet Earth here in the state of Michigan. The Great Lakes of our region represent something like, I'm making this up, but I know it's somewhere between 60 to 80% of all the liquid fresh water on the entire planet is present here in the Great Lakes region. So go us. Side note, that also means that we need to be really good stewards and take care of our Great Lakes and not, pollute them and things like that. All right, the water molecule. So, ladies and gentlemen, the water molecule itself is officially called dihydrogen monoxide. It is a molecule. The reason why we refer this to as a molecule and not just a compound is because it is a covalent bond. How do I know it's covalent? Because it's two nonmetals. Anytime two nonmetals get together, hydrogen is a nonmetal, oxygen is a nonmetal. Whenever two nonmetals get together, they make a covalent bond. The two hydrogen atoms and the one oxygen atom, have a polar covalent bond. So if you recall from the video yesterday, what it means to have a polar bond means that they're not again covalent. They share electrons. Excuse me. In a polar covalent bond, they're not sharing equally. The example that I always talk about when I talk about polar covalent bonds is I tell a story about myself. I am a middle child. I have three older sisters, one younger sister, and a younger brother. And growing up, I always like, and if you have younger siblings, you know this. Um, Whenever you have something, it doesn't matter what you have. You could have chips, you can have a soda, you could have candy, you can have French fries. It doesn't matter. Whenever you have something, your younger siblings who are much smaller than you always come up and they're like, give me some. And you're like, no. And then your parents are like, no, you got to share with your little brother or you got to share with your little sister. And then, like, you kind of feel like you're forced to share. But let's be honest, if you're anything like I was, and maybe I'm a horrible sibling, I'll put that out there. I never shared equally. I'm like, well, they're little, and as long as I give them some, like, then I did what mom said, so I can't get in trouble. Like I said, that might make me a horrible person. I get it. But I didn't share equally because I didn't have to, because my whole thing was, what are they gonna do about it? They're little. That's what a polar covalent bond is. It's not sharing these covalent electrons equally. If you look at a periodic table, oxygen is literally 16 times larger than hydrogen. Like, literally 16 times bigger. Oxygen, therefore, doesn't share equally. Oxygen keeps the electrons most of the time. Hydrogen only gets the electrons some of the time. So that strong pull from the oxygen creates that slightly negative charge on the oxygen side. The fact that hydrogen doesn't always have those electrons because it's not being shared with equally means that it has a slightly positive charge on the hydrogen side. And that's what makes it a polar covalent molecule. Pole as in, positive on one side, negative on the other. Now understand the overall charge of this molecule is neutral. But again, because oxygen is not sharing equally, sometimes we will see a very slight positive charge on the oxygen side, a very slight negative charge on the negative side, and that's what creates a polar covalent bond. And all right, so we are now on water is a polar molecule. All right, so this polarity of water, this idea that oxygen does not share its electrons equally with hydrogen because it's a bad older sibling, this polarity is what is responsible for many of water's properties. So, water has all these amazing properties, and 99% of them trace back to the polarity of water. The fact that this is a polar molecule, the fact that it has a slightly negative charge on one side and a slightly positive charge on the other side. And again, that polarity is just the difference in that slight electrical charge between the two different sides of this molecule. A polar molecule, again, and we've talked about this, has a slightly positive and a slightly negative charge side. So you can clearly see in the diagram here that oxygen is the negative side, hydrogen is the positive side. Okay. And again, this is like just, it's a slight, it's not, this is not like ionic. It's not a permanent positive negative like ions are. It's just because oxygen is bigger and it holds the electrons for a longer period of time. So it's not sharing equally. Hopefully that makes sense. In your diagram, I know it's asking you to label the atomic symbols, charges, and bonds. So again, negative goes on the oxygen side, positive on the hydrogen side. Hydrogens are the two little white ones. Oxygen is the big red one. And then this stick in between is what we would call the covalent bond. Okay? Issues or questions? All right, hearing none. All right, water's charges. So, this idea that you have the positive side and the negative side. Oxygen is what we say is more electronegative. In other words, it's more electron loving than hydrogen is. It loves its electrons. Again, kind of like an older sibling. I love my chips. I love my ice cream. I love my pop. And I don't want to share, but I'm kind of being forced to. Oxygen is electron negative or electronegative, which means it loves its electrons. It's going to hold on to them really tightly. So the electrons are not being shared equally. And they are a lot closer to the oxygen than they are to the hydrogen. And that unequal sharing is what causes the slight negative charge on the oxygen side and the slight positive charge on the hydrogen side. Again, they are not being shared equally. That causes this polar molecule to exist. Issues or questions? Okay, hearing none.